Welcome to This Explainer. Today, we're diving into something that honestly sounds a little bit like science fiction, or maybe just too good to be true. We're going to explore how basic, everyday dirt can generate free, continuous electricity using a simple device that costs literally $8 to build. So let's kick things off with a number that most of us know all too well. $1,800. That's roughly what the average American household is shelling out every single year just for grid electricity. And let's be totally honest with ourselves here, we're paying more money than ever for a system that's getting increasingly unreliable. Power interruptions are hitting their highest figures in decades. We're essentially just renting our power month after month after month. Now, if you've ever looked into going off-grid, you already know it's not exactly cheap. A basic rooftop solar setup, that runs upwards of $15,000. And those lithium batteries that store the power, well, they actually lose 20 to 30% of their capacity within just the first 5 to 7 years. It's kind of like a subscription plan dressed up as energy independence. But I want you to contrast that exorbitant, degrading cost with an earth battery array. We're talking about an $8 cost for a setup that is virtually permanent, it doesn't degrade, and it really doesn't care at all if the sun is shining. All right, let's get into the mechanics of this. Section 1, how dirt generates electricity. So how is this even possible? Let's demystify the science here. There are actually 3 distinct ways the earth beneath our feet generates measurable power. The main mechanism at play is something called a galvanic cell. Now, sure, that sounds like a super dry textbook term, but it's actually a principle you probably already know. Remember that classic middle school science experiment where you stick a copper penny and a galvanized zinc nail into a lemon to make a little LED blink? Well, that is a galvanic cell. You've got 2 dissimilar metals acting as electrodes, and the lemon juice acts as the electrolyte to carry the charge. The real secret here is all about the electrochemical series. Look at the relationship between these 2 metals. Zinc is highly reactive. It's incredibly eager to just shed its electrons. Copper, on the other hand, is less reactive and is super eager to collect electrons. So when you drop both of these metals into a conductive medium, the electrons have absolutely no choice but to flow from the zinc over to the copper. And that continuous flow of electrons, that is your electrical current. So, in an earth battery, we're basically just swapping out that lemon for wet dirt. Moist soil acts exactly like the lemon juice. It is absolutely packed with dissolved minerals, salts, organic acids, and literally billions of bacteria. When it gets wet, it becomes this highly effective electrolyte. It provides all those essential dissolved ions to carry the charge between your copper and your zinc. Think of it like a giant, dirty lemon that's completely free, it's everywhere, and it never expires. Okay, so let's layer on top of that because there is a second major power source at play here, telluric currents. These are natural, continuous electrical flows moving right through the Earth's crust, and they're driven by the solar wind interacting with the Earth's magnetic field. By spacing your earth battery electrodes far enough apart and aligning them along the north to south magnetic meridian, you can actually tap directly into these natural currents, and that produces an output way beyond what just the basic galvanic reaction alone would give you. And that brings us to the third pillar, which is honestly on the cutting edge of modern science, microbial fuel cells. In a 2024 peer-reviewed study, a team from Northwestern University showed that naturally occurring electrogenic bacteria in the dirt actually break down organic matter and donate electrons directly to buried conductors. This is wild. Their device generated 68 times more power than its attached sensors even required. So this isn't some fringe theory, it's highly documented modern science. Moving right along to Section 2, a century of forgotten science. Now, you might be thinking, if this is all real science, why does it feel like some huge secret? Well, it actually wasn't always this way. We can trace this back as far as 250 BCE with the Baghdad jars, which functioned as early galvanic cells. Fast forward to 1841, Alexander Bain buried zinc and copper plates to continuously power an electric clock. In 1898, Nathan Stubblefield literally transmitted clear human speech through the ground using earth batteries. But man, perhaps the most amazing moment was the 1859 Carrington event. This was a massive solar storm, and telluric currents surged so powerfully through the earth that telegraph operators disconnected their standard batteries entirely and held 2-hour conversations powered purely by the electrical currents flowing naturally through the dirt. Absolutely incredible. Which leads us to Section 3. The structural invisibility problem. So if this stuff has worked for literally 200 years, why on earth isn't it sitting on the shelves at your local hardware store? The answer is something called structural invisibility. The American electricity market is a $400 billion industry, right?
That entire financial architecture relies on centralized generation, long-distance transmission, and metered consumption. Simply put, every dollar depends on an invoice. An earth battery that you just build yourself out of scrap metal, it generates no invoice. It can't be metered, it doesn't have a UL listing, which means no insurance policy will cover it, and no inspector is going to approve it. It isn't even viewed as a competitor. It's just entirely invisible to our current regulatory and financial frameworks. It just doesn't fit the business model.
All right, let's get into the fun stuff. Section 4, building your earth battery.
The beautiful thing about this technology is how perfectly it fits right in your own backyard. Building a multi-cell array is incredibly simple. Step 1, procure your materials. You just need a length of standard copper pipe cut into sections and some galvanized steel nails which are coated in zinc. Step 2, dig some small holes in moist ground, spacing them about a foot apart. Drop one copper section and one zinc nail into each hole, keeping them just a few inches apart from each other. Step 3, wire them in series. That just means you connect the copper of your first cell to the zinc of your second cell, and so on, right down the line.
But hold on a second. Before you rush off to the hardware store, I have to give you a really critical warning here. Do not try to substitute stainless steel or any other corrosion-resistant metal for your galvanized zinc. Stainless steel is specifically engineered to resist corrosion, so if you use it, you're going to completely defeat the electrochemical reaction we were just talking about. You absolutely need active zinc and active copper for this to work properly. Now, let's manage our expectations just a bit. This little setup is absolutely not going to run your central AC. A single cell buried in moist dirt produces between 0.5 volt and 1 volt, with very low milliamps. But the magic happens when you wire them in series, because you start to stack that voltage. 10 cells will reliably give you between 5 and 10 volts. Bump that up to 20 cells and you'll push right up to 10 to 20 volts. The current stays low, but the voltage scales beautifully based purely on how many pieces of scrap metal you bury in the dirt. So what can you actually do with all that? Well, an earth battery array is totally ideal for anything that needs continuous, low-draw power. And the possibilities here are just so cool. You can easily run an LED light strip around the clock. You can power soil moisture sensors, wireless weather stations, or little microcontrollers. If you have a 20-cell array and a simple blocking diode, you can actually continuously trickle charge a standard 12-volt lead-acid battery. And it's going to do this day and night, rain or shine, completely off the grid. And I think that leaves us with a pretty fascinating question to ponder. We've been so trained to expect our energy storage to be incredibly expensive, right? And to degrade over time, constantly forcing us to buy replacements. But the fundamental electrochemistry of the Earth offers a completely different path. If you had a patch of moist ground, would you build a continuous, practically permanent Earth battery array for $10? Or are you content to just keep buying expensive lithium cells that are destined for the landfill in a few short years? Think about the literal power beneath your feet. Thanks so much for joining me on this explainer, and I really hope it sparks a little curiosity for you to go out and experiment in your own backyard.